Hey guys, welcome to another online math class. This video will be our second lesson on trigonometry and will be about finding unknown angles. And by the end of this lesson, our goal is to know the inverse trigonometric functions, be able to use the functions to find unknown angles, and finally be able to find angles in application questions. Let's just pause the video here and take a couple of minutes to write these down. So in our last lesson, we learnt about the three trigonometric ratios and remember them using SO, CAR, TOA. Today we're going to learn about the inverse ratios, and the inverse trigonometric functions are used to find angles in right angle triangles. So these are used to find the side lengths, the inverse are used to find the different angles. And the inverse functions are below, in which this just means theta, or the unknown angle, equals sine to the power of -1 times opposite divided by hypotenuse. When we put this into our calculator, we don't actually type in sine to the power of -1, we just pressed shift and sine and it comes up with that by itself. Alright, so essentially all we did was move sine to the other side and put -1 there. So make sure you know how to convert each SO, CAR, TOA to its inverse, and make sure you write them down into your book so even if you forget them you can refer to it back later. Alright, so let's have a go at using these formulas, the inverse functions, to solve some problems here. So our first one, find the value of theta in the following right angle triangles rounding to 2 decimal places in part B. Alright, let's start with part A. We got that triangle there. We need to first figure out which trigonometric function we're going to use. So let's have a look. That's the opposite, that's the hypotenuse. So it's going to be SO. That gives me sine theta equals opposite, which is 1 over 2. Now I need to change that to its inverse, which equals theta equals sine to the power of -1 times 1 over 2. Once you've got that, pop those values into your calculator. So I've got sine to the power of -1 there. I'll just show you how to get to that again. Just press shift, sine, and you'll get that. And then type in 1 over 2. Close the bracket. And you click to the next part. Close the bracket and press equals, and you'll get a value of 30. Moving on to the next question. We have that triangle there. We currently have the adjacent, because that's the opposite. That's the adjacent, and that's the hypotenuse there. So I'm using CAR. So in this case, I've got cos theta is going to equal the adjacent 1.5 over the hypotenuse 2.5. Just change that to its inverse, which equals cos to the power of -1 times 1.5 over 2.5. And then we're going to pop those values into our calculator. Just clear what you've got there. Press shift, cos to the power of -1. Add in your fraction, 1.5 over 2.5, close the bracket and press enter. And that rounded to 2 decimal places is 53.13. So theta will equal 53.13. Make sure you're putting the degrees sign in there as well. Alright, so now it's your turn. Very similar questions again. Pause the video here, have a go at these by yourself, and just unpause it when you're ready to go through them with me. Alright, so this first one, I've got opposite there and the hypotenuse. So I'm using sine. So sine theta equals 3 over 6. Theta will equal sine to the power of -1 times 3 over 6. And then we're going to pop that into our calculator. And when we do that, we get a value of 30 again. So give yourself a tick if you got 30 degrees. And question B, I'm using CAR again. That's the adjacent, that's the hypotenuse. So it'll be cos theta equals 7 over 9. Theta will equal cos power of -1 times 7 over 9. And theta will equal a final value of 38.94 there. So if you got 38.94 degrees, give yourself a tick. Alright, so we've hit our first 2 goals now. Let's move on to our third one, which is application questions. Alright, so for these you'll have to draw your own triangle. Let's have a read through this. It says a long straight mine tunnel is sunk into the ground. Its final depth is 120 meters and the end of the tunnel is 100 meters horizontally from the ground entrance. Find the angle the tunnel makes with the horizontal correct to 1 decimal place. So let's start off by drawing the shape here. We've got a long straight mine tunnel like that, and it's sunk into the ground. Its final depth is going to be 120 meters. So that's the depth there, and at the end of the tunnel is 100 meters horizontally from the ground entrance. So horizontal means left to right. So the end is going to be 100 meters horizontally. Find the angle the tunnel makes with the horizontal. So we want to find out that angle there. So I'm going to label that as theta. like so. And now we need to find out what that angle is. So I've got the opposite and adjacent. We know it's not the hypotenuse because that's the longest side there. So opposite and adjacent is taller. So that means tan theta is going to be 120. It's the opposite first, over the adjacent, which is 100. So the angle theta is going to be tan to the power of -1 times 120 over 100. Once you've got that, pop those values into your calculator and you should get a value of 50.19 degrees. So theta equals 50.19 degrees. And sorry, it says correct to 1 decimal place, so I should have said 50.2 degrees. That's why it's important to read the question carefully. Alright, now it's your turn. Have a go at this one by yourself and just unpause it when you're ready to go through it with me. So once again, very similar to the one before, it says its final depth is 4 meters. So we know it's going to go down 4 meters. And at the end of the burrow is 5 meters horizontally from the ground entrance. So we're going horizontally 5 meters there. And we want to find the angle. So that angle there, the burrow makes with the horizontal. And once again, we're going to call that theta. So that's the opposite here. That's my adjacent. So I'm using TOA. So I've got tan theta equals the opposite of 4 divided by the adjacent 5. So theta equals tan to the power of -1 times 4 over 5. And then we're going to pop those values into our calculator again. And that's what it will look like in your calculator. And then press enter and you get a value of 38.7. Correct to 1 decimal place. So it's 38.7 degrees. Give yourself a tick if you got that correct. Alright, so that brings us to the end of this video. Hopefully by now we have a better understanding of the trigonometric functions, can use them to find unknown angles, and also can find the angles in application questions. Thank you guys for watching, and I will see you guys all back online.